Okay, so it's time to continue with our panel discussion. So I will give the floor to Alessio Bolognesi, and he will introduce our speakers and your panelists.
Thank you, Guillaume. Good morning, everybody. I hope you warmed up a little bit in the previous session. It's quite cold in here, so maybe you can come over here in the front line so we stay all together a little bit closer. It could be warmer than. Okay, everybody's ready. So again, ladies and gentlemen, welcome to this second part of this symposium. We're going to have a panel discussion this morning on the most, I would say, uncomfortable topics in agricultural robotics. My name is Alessio Bolognesi. I work for Federunacoma, that is the Italian Association of Agricultural Machinery Manufacturers, and I'm the technical officer for digital agriculture, which means everything and nothing, but let's take it as it is. It's my pleasure today to have this discussion because the expectation of people about agricultural robotics is quite high, and sometimes they expect those machines will exceed the human being in performing operations. And they are the variety of agricultural robots is very broad, is very wide. We have kind of autonomous tractors, but also very specialized machines, and to perform very precise and specific operations. And how these machines will interact with among the others and with the human being is part of our world today. And we expect maybe in the future that those machines will not be alone in the field. Maybe they will be interacting with other robots or with humans and with maybe traditional machines. And this opens up the door even to new challenges, right? We're going to discuss some of those topics with our esteemed guest today. We have Andrew Olive, just in alphabetical order. Andrew Olive, the chairman of the Agricultural Industry Electronic Foundation. Clement Baron, technical officer of agriculture, right? Frank Young, I hope I pronounce it well, head of the product engineering in IO, and Rick Weirs, the product safety manager in Balance Engineering. So please give them an applause to welcome our guest today. I will go to 3 rounds of questions to make you uncomfortable. And I hope you have some answer for this audience here. And I will start with you, Frank. So now we're talking a little bit in general about the performance expectations of people in agricultural robots. How are you trying to engineer and develop the product to match the expectation of the customers, but even to exceed or to overcome the actual the current burdens or the current limits of agricultural machineries, and which are the limits of the new autonomous machines? I think about, for example, the running speed in the field, etc.
Okay, thank you for the question. First of all, I think people are I'm comparing the robots with the tractor, which is somehow a mistake, but we cannot do anything else. It's human to compare what we actually have with the new way to do operation in the fields. And in fact, when you're comparing the tractor with the robots, there was also always this speed limit, which is coming up, because it's limiting for some type of operations. But there are some operations which are really at slow speeds, like I think about precision weeding or spot spraying. That operation that could be done at less than 1 kilometer per hour, And in this case, robotics has really is the best solution to do this kind of operations, because a driver on tractor running at this speed is the waste of time for him, and also um, I think the accuracy of the robots is really a good asset for this type of operations. So uh, we have to stop to compare always the tractor with the robots, because we definitely we will lose this comparison. And in fact, there is some case we would like to go over 6 kilometers per hour, because that's the limit under which we are in the machine directive regulation, and not the muzzle regulation for tractors. So we will not to go over this speed limit of 6 kilometers per hour, and that's the main reason we would not to go at the speed. And if we achieve the complete autonomy of the robots, the speed limit will not be an issue anymore, because the robot can run even at night, or under with no supervision. And in this case, it can there is no challenge of matching the working time of the driver. So it's important also to know that it's not a big deal to go slower as far as the tool are working correctly.
Anyway, this has to do a lot with the, how can I say, a new way of thinking for farmers to agricultural practices, right? So it has to change his mind to perform the operation in a few hours.
Yeah,
because it's a kind of game changing.
Yeah, for now, they want to match the working time of the driver or of the people who are launching the robot in the morning and take it back at the evening. So that's a wrong calculation for me.
Okay. Clement, still talking about the role of human being in when dealing with agricultural and autonomous machines. How important is for a manufacturer and maybe for new regulation to find a way to avoid a human supervisor always present to monitor and the machine to watch that everything is working properly? And is this an aspect that could attract new customers, new people to the autonomous machines?
Thank you for the question. Hello, everybody. I will answer your question also taking your word, Frank. You say that comparison is a normal and natural way. I think farmers today are concerned about less of manpower. They worried about their revenues, and so for sure, if we come with a new solution, they will compare. Is the robots more convenient for me than my traditional tractor and machineries? What are their criteria of comparison? Is the work the same? What do I need to change in my workflow? Am I supported for that? Is my dealer aware? But also, um, will it make me? Will it increase my revenue? Will it let me have work in those climate events? And am I more comfortable with that? And so they will compare, and it's normal and natural. And so if we want autonomous machines to gain this comparison, then we have to focus on the return on the investment for the farmer. And for sure, if you arrive with a machine which is slower for different reasons you mentioned, then you absolutely need not to have a human supervisor, so that the machine is more profitable. And so for me, it's not a question. There is just no use staying in the field, waiting for the machine, a slower machine or the same machine. There is no use staying in the field, and so it's an absolute necessity. Yeah, we have to even as a technology provider, as we are in agriculture, we have to focus. We have to focus on what the farmer is waiting for, and I think that profitability and increasing his revenue is the key points today, and especially when you are introducing a disruptive technology, a new way of thinking, a new way of working. It means risks for him, and so if you are not, if your return on investment is not high and really clear for it, it will be hard to gain more to sell to more than early adopters or technology fans.
Thank you. I have then another topic, but I'll take it for the last round of questions because it really deals with the change in the mind of the farmers. But I would like to move a little bit to more technical, I would say, area. So, talking about the activities of the Agricultural Industry Electronic Foundation in the autonomy area. A little more than 1 year ago, you started a new group on autonomy dealing with those aspects and try to understand how AEF should be investigating the autonomy area. Team was already a reality and maybe is part of the suitable technologies to be used on agricultural tractor. But what is in your mind the role that AEF is playing in creating guidelines for these new applications in the autonomy world?
Okay, Alessio, thank you for the question, and yeah, it's a pleasure to be here. So yeah, within the AEF, I mean, we were formed as an organization from interested equipment manufacturers actually around about 2008. So as an organization, we've been going for, 17 years. I've only had one cup of coffee this morning, and really the whole idea of the AEF was that there was this standard called Isobus, which first came out in the early 2000s. People started using the Isobus standard. People started developing electronic equipment to go on the tractor, to go on the implement. But when they plugged it together, it didn't work because the standard wasn't, if you like, it didn't have enough detail in it. And that really led to the need to form the AEF in the first place. As ag equipment manufacturers, we got together, we thought, how can we investigate on a technical level these issues and resolve them? And so that's really, if you like, the foundation or the core of the AEF. And obviously, this subject of autonomy in agriculture has been growing for quite a number of years now. And from the AEF point of view, we've been studying, looking at what was going on, which groups were doing, were taking on activities in the autonomy space. And we thought, okay, there seems to be a lot of activity here. We need to wait and only enter into this if it's a request coming from our members or we see that there's a need, again, for technical cooperation in this area. And yes, Alessio, after a sort of, a couple of years of watching and having some workshops, we decided early last year to form an autonomy team. And the main reason or the main function behind this autonomy team under the umbrella of the AEF is, to look at autonomous machines working in the field, look at that ecosystem and try and understand of all the interfaces that might be going on between the machine and the cloud, or the machine and the implement, or the machine and the sensors. What should be standardized? What could be standardized to help the whole industry move forward at a much greater pace in this area? And that's really the reason behind the team is we look at the autonomous systems working in the field, we decide what are the ones that should be standardized, And once we agree, okay, those interfaces should be left alone to protect manufacturer IP, etc., to protect proprietary solutions. Of the interfaces that need to be standardized, do we have an existing isobus function which could be improved to also suit autonomous application? And so, what comes to mind immediately is the universal terminal function or the task controller function, or as you mentioned, the TIM functionality. And if we can then improve these existing isobus functionalities to then work also with autonomous or unmanned systems, then we're allowing the whole industry to move forward in a much more, dare I say it, coordinated way. And so that's really the task of this autonomy team we've had going now. And I have to say that, typically when the AEF forms a new team, it's because there's a request coming from the manufacturers or from the industry to say there is a problem here. We need to address it. In the history of the AEF, most teams are kind of slow to get going, and then the support comes after a while. And one of the most amazing things about this autonomy team is that they've been really quick to get going. There's been really good engagement from the member companies. They're meeting on a really regular basis, and the progress they're making is really quite fantastic. So, I think it was the right moment for the AEF to form this team. There's good support from the industry, and I'm really confident that within a year or so there'll be something coming out to say, okay, these are the teams which we have, which should be enhancing their product for autonomy. So yeah, it's a really pleasing situation, and I think it really will help the whole industry move forward.
Yeah, even because this is trying to give some technical answer on one of the major challenges, which is coupling autonomous tractor or tool carrier, let's call it that way, and maybe smart implements, right? Because today it's kind of two different things just put together, and I hope they work in a proper way. But we expect in the future to have maybe smarter implements coupled to those autonomous tool carrier, and because this is what the precision agriculture is asking for. So very precise and effective operation. Rick, how important is this couple of autonomous tractor and maybe smarter implements work together at in a unison as a whole entity, and which new challenges rise in the safety in the safety areas, let's say?
Yeah, it's extremely important that they work together well. I focus on the safety perspective, so I'm going to talk to that point. But if you have a machine that the implement is telling the tractor, I need to slow down or speed up, for example, the tractor or the operator in the tractor has to make a decision. Is it safe to go now, faster, slower? Or if the implement tells the tractor I need to stop briefly and then restart again, is it safe to do that? That coordination between those activities, between the tractor and the implement, can be extremely important to safety. So that coordination is becoming, it's growing in importance, because then when you start to automate things, right, when you start getting rid of the operator at a certain point, that coordination, I think, becomes even more important, because now the tractor really has to make a decision. Is the path clear ahead of me? Is somebody approached the tractor? Is somebody approached the implement, right? Is the tractor monitoring the implement? All of those activities become extremely complex and important to engage. So now you have multiple control systems talking to each other, saying, okay, I'm clear, I can go forward now, I can't go forward. Those decisions that have to be made in real time, right? The farmer's not going to wait to do this. He needs to have actions, right? Keep the machine doing its function in the field. So that coordination becomes extremely important.
Well, just another quick question, because I figure we're figuring out scenarios which maybe I couple a very big implement to an autonomous carrier, and maybe the perception system of the carrier will be obstructed by these implements. So this is something you can expect in the future, and manufacturers should try a way should find a way to avoid this situation and find a solution, right?
Yeah, the one that comes to mind, a really important one, if you have a sprayer, for example, with a large boom, the tractor might have a perception system to watch the ground around the machine, but things up in the air that are tall and fine little wires dangling across the field may be very difficult for a tractor perception system to detect. So when the boom needs to be raised and transported, or just raised to be folded up, it can be a very dangerous time. So that coordination, trying to know what the attachment's doing and how big is that thing that you're pulling, the implement, how wide is it? Is the camera system developed, or the LiDAR system, or whatever it might be, is it developed to work with that particular implement or not safely? And it's not a trivial thing. It's a very challenging aspect of it.
Thank you. So we talked about having very specialized machines, autonomous tool carrier or tractors, and like I mentioned in the introduction, we are expecting many machines to work together in the field. And Frank, how could this maybe if we just think about agricultural robots working together in the field, how important and how difficult should be to synchronize them to perform a proper operation altogether? Is part of your vision as a company in the next future?
Yes, there's definitely a long-term vision, of course, because for large amount of time we will have in the same farm new material, old material as well, people working at the same time than the robots. So for now, we have designed our machines to have a strong safety system, embedded safety system with a strong detection system to be sure that everything is seen around the robots, and we can detect obstacles to stop when it's going wrong. So for until the day or every machine inside the farm is connected and have the same standard to communicate with each other, to be sure that all the operations are done safely by all the machines inside the farm. Until reaching these points, we have to have this strong safety system, embedded safety system, to be sure that to have the right obstacle detection. But I think we could achieve, and it's definitely our vision, to have several robots or machines working together in the farm. So for that, we need at least a standard. That's why I asked AEF to work on that, to have at least the machine sharing their position, the location in the field, of course, and what kind of operations they are doing. And I think the next level is to maybe a collaborative work in which one machine has detected one situation that can be handled by another machine in the fleet, so we can just have a task management for the whole fleet of available machines in the farm. So that's definitely our vision, and that also can be also coupled with weather informations and all other environmental sensors that are capable to say, okay, it's okay to go in the field doing this kind of operation depending on the weather and the soil conditions, for example. So yeah, that's our vision, but I think we need time to achieve that.
Yeah, I envision something like a distributed mind of these these machines in the future. Yeah. And Clement, what if you figure out this scenario in the future? What are the technical challenges that remain to solve to ensure this multi-robot environment collaboration? Like, think about I don't know, infrastructure or sensing or whatsoever.
Okay. First, I would like to mention that it's not only future. In agriculture, we provide our customers systems that make their machines working together today. When we started with a small machine, smaller than huge tractors implements, for instance, for soil compaction purpose or for transportation. We realized that we had to make them work together. And when we started, we wanted, we needed to solve two main problems. First one is the collision. We don't want collision between machines, but also blocking situation. When you let several machines in a field, you may have a blocking situation. Oh, I went to reload and to refill, and so we developed swarm management systems for all machines to work together with different operations, integrating different constraints. Okay, look, I prepared the soil, then you can go seeding. And so you can have several machines with different operations, or several machines with the same operations have problems, and the other machine is coming to work. So this is not future, this is a reality in the present fields with our agricultural systems. Now the challenge is to collaborate and to append, and I think there is no technical issue. I think infrastructure has to be reduced at maximum, and so now it's a question of more at AEF level, and how do we want to collaborate between manufacturers?
So the multi-brand environment is a challenge to be tackled, and that's why also AEF worked on a technology which is called the wireless in-field communication, which could be part of the game on the technical solution to allow the machine to communicate with each other, machine-to-machine communication, etc. Maybe by sharing coverage maps and so on. So. Is WIC a possible solution for this scenario we just figured out, and what are the use cases that AEF investigated that could be applied for autonomous machines?
Okay, just before I speak about WIC, I'd actually just like to start talking about TIM, and apologies for all these acronyms, but TIM refers to Tractor Implement Management, and it's a functionality which was released by the AEF in 2019. TIM is an evolution of what was commonly known in the market as Isobus Class 3. The problem with Isobus Class 3 is that if you had an implement controlling a tractor and you didn't have, if you like, a secure or a trusted connection, if there was an incident, you would never know who was at fault. And that was really, again, why the AEF started working on how can we enhance this idea? And that is what ended up being released as TIM, or Tractor Implement Management. The whole idea with TIM is that you have a smart implement, an implement which not just says I need hydraulic flow, I need PTO, rotation, whatever, I need electricity, but an implement which actually has enough sensors on itself to say, okay, I know how fast the tractor needs to go to get enough crop coming into the implement, so I can make a nice bale. With a camera, I can actually steer the tractor as well. So with the smart implement, we're talking about the implement getting the functions that it needs from the tractor to do the best possible job. If you like, it's just turning the tractor into this power unit, which in theory could be unsupervised. However, the way everything's written today, the way TIM is developed today, you still need the operator in the seat. You still need that person there in case anything goes wrong. But if you have TIM engaged, then the system manages itself. The tractor and implement work together, and the implement controls the operation. It gets the right sources from the tractor to do the best possible job. And this is really obviously where we want to go. We want to evolve TIM to work without an operator, so that again it can suit this autonomy. Now, you also mentioned this other project, the team that we have going called wireless in-field communication. And the main reason behind and again, sorry, WIC is the acronym there. So the main reason behind forming this WIC team is that we realized, okay, we have machines from different manufacturers working in the field. You have one color tractor and another color implement, and they communicate seamlessly via isobus. Now, when you have machines working in the field, but they're not actually connected by a wire, so you can have a forage harvester unloading into a tractor, for example. They could be from different manufacturers, and there's obviously no wired connection there. But can they communicate wirelessly? How can we enable that to happen? And that was really the reason behind forming this WIC team within the AEF to investigate what are the possibilities for infrastructureless wireless communication in the field. And this team started looking at really 4 use cases. The first one was process data exchange. So let's imagine you have 2 tractors and 2 planters working in the field from different brands. The idea being that with process data exchange, they can share coverage maps, they can share information on where they've driven, where they've just planted, so that one tractor doesn't plant where seed's already been planted by the other tractor. So process data exchange, that's one of these use cases for WIC. Another use case would be a camera and a remote terminal. So you have a camera, filming an image, but the actual terminal where you view that image is on another machine. And so that information would again be communicated wirelessly. The third use case is, again, sort of moving slightly into the autonomy area, is if you have a cooperative machines. So if you have a combine and the tractor with the grain cart comes along and they have to drive parallel while the combine unloads into the tractor, that's a third application for WIC, where the actual combine driver would take control of the tractor speed and the tractor position to make sure that the unloading process goes well. But obviously that's control of another machine within close proximity. That particular use case doesn't cover those machines being a long way apart. And then finally, the fourth use case for this WIC technology is road safety. And it's the whole idea of the tractor or the combine broadcasting a message to any other road users to say, I'm about to enter the road, or I'm a slow moving road user. And for this WIC use case, we've had good collaboration with some car consortiums in Europe and also other parts of the world. And we've identified a particular frequency for this communication. All of these technologies, the intention is to use Wi-Fi. So a particular version of Wi-Fi. And in some parts of the world, we might be struggling with the power of the Wi-Fi, etc. But that's still something we need to address. But really, again, it's wireless and field communication. It's without having to connect to a cloud and come back down. It's direct machine to machine. So coming back to sort of, if you like, the autonomy aspects, obviously the main one there is the combine unloading into the tractor and the grain cart is, that could suit, this technology could suit that. However, listening to what Clement said, you will also have, obviously, in the short term, you can have envisaged manned machines and unmanned machines working in the same field. And if they could be communicating that process data, this is where I've driven, this is where I've driven, to make sure they're not going to collide or do the same work in the same spot, that's a fantastic opportunity as well. So to me, that's something else that we need to bring into the WIC team and say, hey, have you guys considered this aspect of the process data exchange?
Yeah, it could be interesting to, for example, for a operated machine, for the operator to see through his monitor what the autonomous machine is doing, what is in his camera field. So, and so machine to cooperative machine anyway, maybe not robotic, but are already a reality for, in many cases in the field. So the machine-to-machine coordination is an actual thing that is working in the field already. But this integration with the autonomous machine will be part of the game soon. Rick, in your in your perspective, what are the new challenges related to these scenarios, and maybe possible solution? I don't know, like distributed perception, for example, something like that.
Yeah. So one of the challenges is functional safety is a big challenge because when ISO 25119 was written for ag machines, nobody had anticipated the complexity that was coming. So the standard didn't really allow for wireless communication. I was sitting at an AEF meeting several years ago, and somebody says, "Well, there is no solution allowed by ISO 25119, so we're not going to do the project." And I looked at the guy and I said, "Well, no, we need to do the project, but the standard is the problem. The technology is not the problem. There's a technical solution to do it safely. The 25119 was already obsolete basically the day it was published. It needed to be updated significantly, and it's being updated again right now. And when that process moves forward, it will allow those machines to have that wireless communication. Today, the way 25119 is written, ISO 25119 is written, if I start my phone, use an iPhone to start my tractor, then I would have to evaluate the software in the iPhone. I would have to evaluate. I'd have to call up Apple and said, "Can you send me a schematic of all your hardware inside of here? I need to evaluate all your chips. And by the way, have you changed them since last year?" It'd be impossible, right? But that's the way 25119 is written today. Obviously, that's a mistake in retrospect, right? We can do wireless communication safely. We can do handshakes. We can do black channels. There's whole list of ways of solving the problem that are safe and legitimate. And so that's one of the problems, that the standards are not evolving as quickly as the technology is. And then the other problem is the manufacturers need to coordinate it. So they're working without a set of standards that are really addressing the current need, but then also having to talk to each other. That's another problem today. The way 25109 was originally written, um, you would have to know all of your competitors' design criteria. So if you wanted to put a John Deere baler on the back of a CNH tractor, you would have to know the entire control systems on both sides, and the software written there, which is very proprietary in general. You had to know all of that information. So we put provisions in there a number of years ago to allow to have a mixed fleet solution. But in the original 25119, it wasn't anticipated that ever be a problem. So they didn't really have a provision. We added those. So we keep adding, let's say, provisions to allow the technology to move forward. And we're trying our best to leave it open-ended so that when a new solution arises, it can be solved quickly. And then also about the camera systems, the amount of microprocessors that have to interact with each other, their mean time to failure calculations that were originally written that make no sense. They were irrational. It made it impossible, in fact, really to demonstrate compliance with 25119 as it was intended to be used. Now there were some workarounds that were developed, but originally there were no solutions for having a system that might require a dozen or more microprocessors to interact with each other safely. It said, well, these problems, these failure modes stack up, and there's too many there. You can't declare it safe. And in fact, you can. And there's lots of evidence to the fact that you can make it safe. So the standards, the evolution of the standards is really, I think, confusing people. They know the solution's there, they know how to do it, but they don't know how to comply with the standard at that point. That's what AEF is solving, though, right?
I have a
Yes.
hard question. How could we uh, deal with these technologies which is evolving much faster than standardization? Because you mentioned standards are obsolete the day they come out. So you have any solution to that?
One solution, and I think the machinery directive even allows for it, is to meet the intent of the standard as opposed to the letter of the standard. Today, you don't literally have to comply with 25119 to sell in the European Union. In fact, I would argue that very few manufacturers are fully compliant to 25119. And really the reality is that you really have to make the machine safe. If you don't, especially if you're a large OEM, you won't get away with it very long making an unsafe product. If you're a very small manufacturer, you might hide for a while, but sooner or later you'll have problems. So really to meet the intent of the standard as opposed to the letter of the standard, I think is a step one, especially in the European Union. In some other markets, though, that can be a challenge. They pick up ISO standards and they encode them literally, and they require third-party certifications in some parts of the world. That's a problem. But in the European Union, at least, there's some flexibility still to allow to meet the intent, not necessarily the letter.
Okay, thanks. Now we move a little bit. Well, we're almost running out of time, so I beg you to keep the answer short. Even if we started a little bit later, so maybe we have some more minutes. But anyway, I'd like to investigate a little bit the environment in which the autonomous machines are moving, with some question about what should change in that perspective. Frank, in terms of the habits and how the farmers are using or approaching the machine, what should change, and how can, even more interesting, how can a manufacturer help the farmer in adopting an autonomous machine in the farm?
Yes, as robot manufacturers, we learned a lot during the past few years because we learned that the adoption is a long process. Adoption of the robot is a long process in the farm. That starts with the sale process because our dealer network and people of our company are working a long time with the farmer to help him change his mindset to be sure that he can use the robots in his farm. Then when he has the robots, we have a long process with our customer success team to follow up to follow the first steps with the robots to be sure that he's doing well and is improving his usage every day, because the key for us is to adopt these robots, because after that, if it's a success with this customer, it will testify that it's working, and it's really valuable for us, for new customers, because it has to change his habits, of course, because you have to use the robots and change how maybe a little bit how the fields are done, and other things like that. So they have to change their habits, and people at NIO or our dealer network as well are spending a lot of time to follow the customers. I don't know what to say more about this.
Oh, for example, a quick question, but I have the same maybe for Clement later on. How much is the machine needed to match the farmer expectation, and how much the farm should change when introducing an agricultural machine in terms of agronomical practices, or the shape of the field, like you mentioned, or whatever?
Yeah, I always take the comparison with the vacuum robots, because with the vacuum robots, you have your room and you launch the robot, and the first time you're using it, sometimes it takes some wires in the ground, or maybe it's blocking on the chair, and the next time you just change the location of the chair, you are putting on the table, and the job is done completely without intervention of a human being. So that's quite the same with the fields. If you just change maybe some path could be difficult for the robots. So there is an adaptation of the farm to be sure that the next time the jump would be done without an interruption requiring somebody goes to the robot and restart it because there is a false triggering of the safety system, for example. So that's a long time, and I think it takes maybe 2 years of operation to be sure that you are using the robot at its full performance, with all its capabilities, to be sure that it's okay.
Okay, and when again we think about these machines moving in the farms, uh, my expectation as a farmer could be I would like to forget about the machine totally over the day, right? So maybe the machine should work in different fields, should maybe go to recharge the batteries or whatever. Which are the new challenges related to those scenarios? How important is to, for example, to allow those machines to cross a farm road to move to another field? Or maybe how important is even the autonomy for those machines to allow the farmer to not always being in the field to do some operation?
This is a large question. I think we have different.
But just a few minutes, right?
Yeah, a few minutes.
I'm kidding.
For transportation and how a machine is moving from one part of the farm to the other, I think it will really depend on the configurations. If you have a vineyard and that your 50 hectares are closed or close one to each other in a private road, then you can find a way for your autonomous machines to go from one plot to the other with no major difficulties. When you have, but when you have bigger fields, you may have, or when fields are further one from the other, then you need to consider the transport. But one key point is that the farmer should not worry about the availability of his machines. So either the machine is fully autonomous and with very few faults triggering for safety reasons, but you also may have a control center, a remote control center, for as an insurance for the user, a comfort insurance. Your machine is autonomous, but no, don't worry. Someone is able to detect if there is any default and resume the mission if you had to do a safety check. And so we need the farmer to rely on the availability of the machine. We need to make him confident that there is no risk for a job not to be done.
Thank you. And Rick, in this scenario, just figure out when the machine is doing something more than operating in the field, let's say in that way, without specifying what, which are new scenarios or new risks which arise from those situations which the machine is moving, maybe across the fields, and is something that should be tackled in the next future?
Yeah, some of the challenges are the terrain. For example, if you have a very steep incline and then you crest it, the sensing technology can't see over the other side of the crest. So that's one of the challenges, and I don't know the solution other than going very slowly, because when you start to come down the hill, the machine tends to go very fast and bounce over the hill a little bit. So that's a problem. Also dealing with dust. I don't see it here, but in the US, there's a lot of very dry places where the dust is creating huge problems for cameras. It's almost impossible to use a camera system in some locations.
Well, I have a question because what you mentioned, we are demonizing sometimes the autonomous machine, right? But the problem is actually present even with a human driver, because I can see beyond the hill, right? So
yeah, what a human does, a number of things. So a human has memory. They know that there's a building nearby with children in it. For example, a school, for example, is adjacent to their field. A camera system doesn't know there's a school nearby, right? A camera system doesn't know when a pickup truck has entered the field on the other side and is driving around on that field, and there's people in the pickup truck walking around now. an operator is aware of that, but a camera system doesn't know that. It doesn't track obstacles that are off in the distance and remember where they are. So this is an area I think of maybe great importance over time to emulate what a human operator knows, what a human operator learns. A human operator knows where the field floods, right? Every spring there's going to be a small lake in that part of the field, and they drive around it. But the autonomous operation may not anticipate a flood, right? It may not know that it rained yesterday and try to drive through it. So.
Thank you. Okay, we are running out of time. Andrew, the last question is for you, and then I believe there is no more room for question for the audience today. I'm sorry for that, but just to close this discussion a little bit, what are the best practices that, as a whole industry, we should adopt to ensure the efficient and effective operation of this autonomous machine in the future? And do you see new critical areas in where AEF could be present to solve some of the issues with guidelines or?
Okay, so I shall now embark on my life story, but there's no time for that. No, really, there's kind of two things. The first thing is that, you know, we have autonomous machines on farms today, and we have manned machines on farms today. To me, the first thing is making sure that the farmer can get the data from both machines in the same place so they can analyze their operation. You know, and whether it's the wonderful ISO XML or whether it's another data format, but it's providing the data in the same format for the farmer is kind of, you know, the most urgent need. And then, yeah, you know, in the long term, autonomous machines, manned machines, they'll typically be working in different fields, typically. In the future, I can imagine that they will end up working in the same field, but this is where we spoke about the wireless, and we spoke about having this coordination to understand, you know, for the person driving the manned machine to know exactly where the unmanned machines are. So I think we're all moving in the right direction. And, you know, again, from the AEF point of view, we've got some pretty strong teams working in this area. But I just think that, you know, wherever there's a possibility to get involved in some standards organization or some industry organization to cooperate on this, the more we do as companies, the more we can support these initiatives, the more we can move forward as an industry to provide something better for our customers, for the farmers, to give them the satisfaction that they need to get the work done that they need to get done.
Thank you, Andrew. Thank you to all of our speakers. Thank you, Clement, Frank, Andrew, and Rick, for being part of this this discussion. I hope it was interesting for you as it was for me. And have a nice rest of the day here in FIRA.